Hello everyone, welcome back. In our last video, we looked at how Thumb-1 handles arithmetic and data movement under strict 16-bit constraints. In this video, we will explore the logical shift and comparison instructions available in the Thumb-1 instruction set for the ARM7 TDMI processor. Let's start with the logical instructions. Thumb-1 supports the core bitwise logical operations such as AND, OR, exclusive OR, bit clear. All four instructions use the same simple two-operand syntax: AND R0, R1, OR R2, R3, exclusive OR R4, R5, bit clear R6, R7. In every case, the destination register also acts as the first source operand. For example, when we say AND R0, R1, it performs R0 and R1 and stores the result in R0. There are two important restrictions to remember. Low registers only, that is, all operands must be low registers from R0 to R7. No immediate operands. These logical instructions do not support immediate values. If you want to use a bit mask, you must first load it into a register using a move or a load instruction and then perform the logical operation. Shift instructions. Thumb-1 treats shifts as dedicated instructions. Thumb-1 provides logical shift left, logical shift right, arithmetic shift right, and rotate right instructions. For immediate shifts, LSL, LSR, and ASR allow a separate destination register. For example, LSL R0, R1, #4. This shifts the content of R1 left by 4-bit positions and stores the result in R0. For register controlled shifts, Thumb-1 uses the familiar two-operand format. For example, LSR R0, R1. This shifts the content of R0 right by the number of bit positions specified in R1. Just like the logical instructions, register control shifts are limited to the low registers. One important difference is that ROR is available only as a register controlled instruction in Thumb-1. Compare and test instructions. Now let us look at the instructions used for comparisons: CMP, CMN and TST. Unlike arithmetic or logical instructions, these never store a result in a destination register. Their only purpose is to update the conditional flags in the current program status register or CPSR. The standard compare instruction is CMP R0, R1. This performs R0 minus R1 and updates the conditional flags. Thumb-1 also provides an immediate form, that is, compare R0, #10, where the immediate value is an 8-bit constant. This form is also limited to the low registers. One unique feature of compare is that it can directly compare high registers. Both of these are valid Thumb-1 instructions, making compare one of the few Thumb instructions that can directly access the high registers. Next is the compare negative. Consider this: CMN R0, R1. CMN performs an addition solely to update the conditional flags. It is mathematically equivalent to comparing one value with the negation of another. Unlike CMP, CMN is restricted to the low registers. Finally, we have the test instruction TST, that is TST R0, R1. This performs bitwise AND operation solely to update the condition flags. It is commonly used to test whether specific bits in a register are set or cleared. Like CMN, TST is also restricted to the low registers. Thanks for watching, and I'll see you in the next video.